Welcome to the Algebra 1 video on direct variation. This one's going to be pretty short. We'll just go through what the definition of it is, what the equation of it is, and then two examples, and you'll be on your way. So direct variation deals with the idea that in nature, sometimes when two variables are related, they're related in such a way that when one goes up, the other one will also go up, but not just in general, but by a specific ratio. So remember, a ratio means the number you multiply by. So if one variable goes up by like 3 times bigger, the other one is also going to go up by exactly 3 times bigger. Or if one goes down by like 5 times smaller, then the other is also going to go down 5 times smaller. But the point is, they go up and down together with the same ratio. So whatever the multiplier is, or divider, will be the same for both sides of the equation. So the equation is going to be y equals kx. So the two variables are y and x, and then the k there, the k is called a constant of proportionality. So what that means is, these two values, it's true that when one goes up, the other goes up, but they may not have the exact same numerical value. One of them might always be like 3 times bigger than the other one, or 10 times bigger than the other one. So the k there is called the constant of proportionality, and it tells you the numerical relationship between your x and your y. So at this point, it might be nice to think of some examples. So for example, your height and the length of your shadow. Those could be two variables that are directly related. So for a taller person, they're going to have a longer shadow. So when one variable goes up, the other variable goes up. But your actual height and your shadow length are not necessarily the same. So there's some constant of proportionality. Maybe your shadow is always exactly half of your height at a certain time of day. So then the constant of proportionality might be 1/2 or something like that. Another example is mass and weight. So if a person has more mass, then they're going to have a larger value for their weight. And there's a constant of proportionality between those, which is based on gravity at the place where you're located. So if you're on Earth's surface, the constant of proportionality is 9.8. Your weight is 9.8 times whatever your mass is. But if you have more mass, you're going to have more weight. And if you have less weight, you'll have less mass. A third example is speed and distance. When you want to go somewhere, the faster you go, the farther you can go in a given amount of time. So in a given amount of time, then your two values, speed and distance, are directly related. Okay, that's mouse. So in any given problem, it's important to remember that even though you have three variables, k, y, and x, only y and x are actually variables that are changing within this problem. So the x and y change with respect to each other, and k is constant for that given problem. But in every different problem that you solve, k could be different. So usually the first thing you'll do when you're solving a problem is figure out what the constant of proportionality is for that particular problem. And then once you figure out the value of k for that problem, it stays the same within that problem, and x and y can go up or down with each other. Okay, so let's apply that knowledge to a couple of example problems. Suppose x and y vary directly. So as soon as you read, suppose x and y vary directly, you should automatically be thinking in your head, that tells me the equation y equals kx is what I'm going to be using. And now it says, when x equals 5, y equals 20. Okay, so that bit of information, if x is 5, then y is 20. That will tell you, or give you enough information to solve for the value of k. So let's plug it in. X equals 5, k we don't know, and y is 20. So we have 20 equals k times 5. To solve for k, of course, divide both sides by 5, divide by 5. And so the value of k is 4. Okay, so once you know the value of k for this particular problem, then you can start answering other questions about it. So then they ask, what is the value of x when y equals 40? Okay, so now we can solve using the same equation. We plug in y equals 40 equals, but this time we know the value of k because it's the same situation, so the value of k stays the same, so it's 4. And then the value of x is unknown. So now we can solve for x, and we get x equals 10. So the final answer is x equals 10. But along the process of doing that, it's often useful to find the value of k. That will often help you out. Now let's look at overall, just this idea of one variable going up and the other going up. So what is the value of y at the beginning? Starts off with y equals 20, and then y goes up to 40. So you can also analyze these problems using ratios. So if y goes from 20 up to 40, then y got twice as big. Okay, so whatever one variable goes up by a ratio, the other variable goes up by the same ratio. So if y gets twice as big, then x has to get twice as big. So x started off as 5, and just as we calculated, x ends up at 10. So sometimes, if the numbers are really nice whole numbers, it's easy to work out. You can use ratios as a shortcut. But if ever that doesn't work out, or you forget, or you're a little uncertain, you can always rely on this equation, y equals kx. That's kind of your backup plan for all these problems. Okay, let's do one more example. Suppose x and y vary directly. Again, that tells you y equals kx. And suppose y equals 10 when x equals 8. Let's plug those in. Plug in a 10 for y, and plug in an 8 for x, so you can solve for k. And we get k equals 10 over 8, which if you use your calculator, you'll get 1.25, or 1 1/4. Okay, now let's find what is x when y is 35. So we plug in 35 for y. We plug in our 1.25 for the k, because that's the value we found for k. We plug it in right there for k. And x is the unknown that we're solving for. So we solve for x, divide by 1.25, divide both sides by the same thing. And we'll need a calculator probably for this one. Let me whip out my calculator real quick. We've got 35 divided by 1.25, and we get 28 as our answer. So the value of x is going to be 28. Okay, so here's one. You may not be able to do the shortcut in your head, but it will make sense. So the y value went up from 10 to 35, so it's exactly 3.5 times bigger. So the x value has to be 3.5 times bigger. So it goes from 8 up to 28, which is 3.5 times bigger. So it's kind of cool. You can set up a ratio for these guys. And let me write down the ratio method real quick, just as a final note. Because y equals kx is constant, if you solve this for k, you get k equals y over x. And that's a constant. So what that allows you to do is it allows you to set up a ratio y1 over x1. So those are your x and y values at the start, or in one situation, are going to be equal to y2 over x2. So this ratio here allows you to calculate an unknown value for direct variation. So this is important. This ratio only works for direct variation. We'll see in the next lesson a different type of variation where you might be tempted to use a ratio, but you have to be very, very careful. And always use common sense to check your answers. When one variable goes up, the other variable also has to go up. So always use your intuition to check. All right, good luck, and don't forget to fill out the form.